Welcome back, magical people of Build Stuff. My name is Rakas and I'm moderating this stage. I'm very excited about this next presenter that I would love to introduce right now. His name is Jonathan Mills, and he's a Pluralsight author, technology advisor, and business leader. As a member of the multi-cloud team at Worldwide Technology, Jonathan is able to take on the most challenging problems our customers face and provide innovative solutions involving cloud strategy, migration, optimization, DevOps, and data management. As a dedicated developer community leader, Jonathan serves on the board of directors for the Kansas City Developers Conference, Microsoft MVP, and is a regular speaker and keynote presenter at conferences around the globe. So, Jonathan, the virtual stage is yours.
Thank you very much. It's always weird for me to hear that all read out. Like I never really pay attention to what it says, and so I hear it all, and I'm like, "Wow, that's a lot of words." But the funny part about that is we say, I speak at conferences all over the world, and for the last year, I've spoken at conferences all over the world, sitting in my basement, which is that is what it is. And for the record, so I think many of you are you're in Lithuania or the Ukraine or kind of in that region. And so I am from this spot right here. So the United States is a kind of a big place. So when you say John's from the States, I'm from the very middle of them, and it's from a city called Kansas City, which ironically is in Missouri, not Kansas. So just for the record, Kansas City is in Missouri. But I'm kind of right there in the middle. I'm a little sad because Vilnius, I've been speaking at Built Stuff for a couple of years now, and usually the night before, I'd be hanging out at literally my favorite restaurant in the entire world, Queensbury, right there in Vilnius. And this would have been my night last night, but instead, I'm sitting here this morning with my own cup of coffee, ready to talk about serverless architecture and events and messages and just how we kind of build things in the cloud, which is interesting, right? Because I think many of you are in this same situation that I find myself in all the time, which is we have an application or we have a problem we want to solve or we've got something and someone says we need to take this thing to the cloud. But sometimes they don't necessarily understand why. They don't understand what problem they're trying to solve. They don't understand any of that stuff. It's just, hey, cloud is the cool thing right now. Let's do that. And so I want to add some context to that as we kind of talk through, because this is the big joke, right? There is no cloud. It's just if I used to say, if you knew where the data center was, then it was a data center. If you didn't know where the data center was, then it's the cloud, right? All the cloud is a data center somewhere else. And that's not actually true anymore, right? Because now the cloud isn't just servers, right? It's not just, hey, I'm going to take my VMs and I'm going to push them up to Azure somewhere or something like that. What I'm doing now is I'm using a set of services that don't exist anywhere else, right? There's cloud services like service buses and event management systems and cloud native databases and all of these things that only exist in the cloud. And so when we take our applications to the cloud, this is my life often, right? Somebody wants to move to the cloud. We just want to lift and shift, right? We just want to pick up our VMs and drop them out there, and they don't get as much benefit out of it as they would like to. My role in the cloud, in the cloud team that I'm on, is to rebuild architectures. So it's like, hey, you have this application here on-prem, and if you want to make the most of the cloud, you're going to need to spend some time and pull this application apart and add a layer of refactoring and re-architecting in the middle that's going to make use of the cloud services that are available to us. It's not just Kubernetes, right? I mean, Kubernetes exists there. That's cool. Let's containerize things, but that's not the end all savior of a cloud application. So think about an application for just a second, right? You've got a front end, you've got mobile devices or laptops or web pages or whatever you want to do there. You've got the middle piece, and then you've got the database. And we often talk about this, like we've got a server or a client team, you know, they're JavaScript, HTML developers, you've got your backend developers, we're just your backend developers, right? And then you've got your database. Well, this box is actually significantly larger than we pretend it is, right? So the front end is the front end, and I do a lot of front end work. I'm not minimizing the front end work, but it's, you know, you've got React or you've got something on the front end, and you've got HTML and CSS. It's complicated and it's there. And then you've got the database, but this box that's in the middle can be very complicated with a lot of stuff in it. And that's going to be the crux of what we talk about over the rest of this talk. Because really it's multiple pieces, right? The box isn't just a little box, it's a whole bunch of boxes that all talk to each other. And in a normal application, I say normal application kind of air quoted, right? I've got let's say GraphQL. I'm a huge GraphQL fan. If you have not started using GraphQL or playing with GraphQL, I would highly encourage it. Basically the benefit of GraphQL in this context is it lets you shape your data as you're pulling it out. So you only are pulling out the pieces that you want and need, not everything holistically. Right. And then in the middle, you've got some sort of event management system. And that's going to be the crux of what we talk about here. So we'll go through what event management is and all of that stuff. And then at the end, through this whole thing, something has to do work. Right. So the event management system is just a broker. It's going to send messages and fire events and those types of things. But at some point, something has to do work. And so we tend to use a lot of functions or web apps or just code that sits out there. I love functions. I love the Azure functions because, so check this out. Really, I don't have to have one backend piece of code. I don't have to have one application. And people will toss around like microservices or things like that. I'm not going to use buzzwords when it comes to this, but if I can break my application up into discrete functions and start building out functions over on the side that say, hey, you deal with this thing or you deal with that thing. If the thing at the top starts to slow down, I can just scale that up, just that piece. I don't have to scale everything up. All my other functions can stay where they are. I can just scale up the one piece that needs to get faster. And I can scale it up a lot. It's not infinite, obviously, but it is. It'll scale significantly farther than you need to take it. I'll just put it that way. But only the one piece. And so this is massive cost savings. If you only have to scale a little piece in order to deal with a load instead of scaling everything. So let's go through an exercise, just kind of real quickly. Let's think for a second, what does it take if I'm going to add a user? So I've got a user in the system, and I'm going to add a user to my application. So on the front end, I take a post, right? So we're gonna GraphQL, everything's a post, but I'm gonna post add user. I've got a mutation, and that's what it does. I want to drop a message somewhere and say, hey, we just added a message, or we just added a user. That's all we've done. User has been added. Now I need things to happen, and so I can break it up across the different routes and say, hey, I've got some auditing that needs to take place. I've got to go set permissions for this user over here. I've got to do some AD integration over on this side. And I can break that workload up across multiple things instead of having one code base and one set of code that goes and builds all this out. And the reason why this becomes important, one, scalability, but two, you can switch these out. right? If I need to change the way permissions works, I can just change it. I can change that one little piece of code and not have to redeploy the entirety of the application. Okay, but this middle piece is difficult, right? Because what do you use for event management? And that's one of the struggles with Azure or AWS or any of those systems is there's a lot of options, right? And sometimes knowing which tool in the toolbox to grab is the hard part. Like once you get the tool, there's docs. You can go out to, docs.microsoft.com, or AWS has docs, and you can go and pull whatever you want to. But knowing which tool is sometimes half the battle. All right, so think about this. 9 times out of 10, I know people grab Service Bus. Service Bus is the concept of Service Bus has been around for a very long time. That's what we do. So everybody just goes and grabs a Service Bus, and it does the job most of the time. But then we have Event Hub. What if I'm just doing events? Like let's just use Event Hub. But then we have Event Grid, right? And so we've got Service Bus, but then we've got these two event systems that they all kind of seem like they do the same thing: Service Bus, Event Hub, Event Grid. And so understanding which one of those three tools to pull is the important piece. And and as you walk through this, always, the first thing you need to understand, just for yourself as you kind of think through this, is what's the problem we're trying to solve, right? What is specifically the task at hand, and what are we trying to do? And so the first topic in all of this is, what's the difference between an event and a message, right? So I've got events, and I've got eventing, and I've got messages. And those are two very different things. And so as you're working through this, you need to think to yourself, what is the thing that I'm keeping track of? Is it an event or is it a message? And so real quick, let's walk through this for a second. So an event is just a notification. Hey, something happens. A file was added to a S3 bucket, or a user logged in. Just so you know, this user logged in, or a trigger condition occurred on a database, or it's just a lightweight little notification that says, hey, something happened. Now here's the thing about an event: the publisher of the event, so the person publishing this thing, doesn't care. They don't care what you do with it. They don't care how it's handled. All they care about is the fact that it happened. And so they're going to stand up and they're going to say, hey, just so you know, this file is added to this bucket. And they're done. That's all they care about. And then it's up to the consumer of the application to decide what to do with it at that point. Right. So the cool part about this is that since there's no expectation of what's going to be done with that thing, all you have to do is just add a new logging mechanism, or add a new auditing mechanism, or add something else that's going to go process a file when it sees it. It doesn't matter from a publisher perspective what happens, and that gives you a lot of freedom to just kind of do whatever you want or add whatever you need kind of as you work through it. So there's also two different pieces of this, right? So you've got discrete events and a series of events. And this is another interesting dynamic when it comes to figuring out which tool you want to do, right? Am I dealing with just an event? An event happened and that's it, I'm done? Or am I dealing with a series of events where lots of things are going to happen and I've got lots of things I have to do? And those are something I've got to figure out. So let's talk about a discrete event, right? So a discrete event reports a state change and it's actionable. So a file was added to an S3 bucket is a perfect example of something that needs to happen, right? Discrete events report state changes that are actionable, and all the consumer of that event needs to know is that something happened. And they're going to get the event and they're going to move on, and that's it. It's over, it's done. But this is an interesting and a very important distinction. The event data has information about what happened, but it doesn't carry the data that triggered the event, right? So when a user logs in, you might get a user ID. Hey, this user ID has logged into the system, but you're not going to get the user. Or you might say, hey, this this file was added to this S3 bucket. You'll get the file, or you'll get the like file name, but you're not going to get the file itself, right? So the event only has data about what happened. It doesn't have the actual data itself. That's something you've got to go and pull after the fact. All right, that's a discrete event, a very specific thing that has happened. The alternate to that is an event series, right? So I have a whole bunch of events that are occurring, and I need to understand all of them over time, right? So series events report a condition, time ordered and interrelated. So if you've got a whole bunch of IoT devices or that are tracking the condition of a piece of equipment, and you want to understand how that equipment is being used over time, or you're doing log streaming and aggregating logs across a bunch of different applications, and you want to understand the time and the order that these things happen, that's a series of events. They're no longer individualized, discrete things. They're a whole series of events that I need to understand and track in context. Right. So the consumer needs to understand the series in order to understand what's happening at all. It doesn't make sense for this one piece of data from this IoT device. I need to look at the entire window of time and understand the entirety of what has happened as we walk through this. Right. So that's events. That's events, right? So you've got discrete events, you've got time series events, but it's just a little nugget. Like it's just a little piece of information that kind of gets you moving in the right direction, and they don't care. So what's a message then, right? Because a lot of times like that sounds like all I need, right? I just get the little event and I'm done. Well, a message is actually maybe a little bit easier to understand it and put context in, because a message is just data produced by a service to be consumed or stored somewhere else. The difference between an event and a message is the message actually contains the data. So I'm going to send you everything you need in this message, right? As opposed to just, hey, this thing happened, go figure out what's going on. It's here's all the data you need in order to get something done. Here's the other difference. The publisher of the message has an expectation about how the consumer handles that message. So think about so in America, in English, we have the 5 W's is what we call it: who, what, when, where, how, which isn't really a W, it's an H, but whatever. But if you know who's getting the message, what they're doing with the message, how the message is being processed, when the message is, if you know those things, you're talking about a message. You're not talking about an event anymore, because now there's a contract that exists between your two sides, and these things need to happen and these things need to get done. In other words, a message needs a response. A message needs to be very clear about the thing that's happening. So the perfect example here is a new user signed up. When a new user signed up, in order to tell the user, hey, you're signed up, there's a whole bunch of stuff that needs to happen in order for you to clearly understand that that is done. So you can tell the user that it's done only when it's done, right? So you need to know these are the things that have happened and that's what's going on. All right. So that's events versus messages. So that gives you Event Grid, Event Hub, and Service Bus. Like which one of these tools do I pick when I'm starting to do all the stuff that we've been talking about? And so with the lens of Event Grid or events and messages, let's take a look at these three tools, and I'll help you figure out the one that works best for your situation. All right, let's talk about Event Grid. Now, first and foremost, Event Grid is a pub sub kind of model. And so just to clarify for everybody, so pub sub or publish subscribe is essentially there's a topic. Let's say file change. And there's a file change topic. And so when an event happens, I'm going to publish on the topic, hey, this thing happened. And everybody who subscribes to that specific topic gets that event. And so you just label everything. Hey, here's a topic. I'm going to publish to that topic. Everybody around me subscribes to that topic. And so I'm pushing events through this system. Now again, so here, this you've seen before. Publishers emit events, but have no expectation about which events are handled or what's going on with them. So we're dealing with events, which is kind of obvious, like in the name Event Grid. We're dealing with events here. And so the idea is I'm just going to push something up to Event Grid and have it be done. And so then subscribers, which get these events pushed to them, decide which events they want to handle and what they want to do. And you can just add new things to a subscription, and it'll go and just send it out to as many people that want it. Everybody's going to get it. It's not only one person gets it or one thing gets it. Everybody who subscribes to this thing is going to get that thing. Event Grid, also, just this is important. I keep saying the word S3 bucket. And if you guys are thinking I'm crazy because an S3 bucket's AWS, most of the stuff I'm talking about is Azure. And that's intentional, right? Because we don't have to use just one cloud, right? Event Grid can use Azure resources, and it can also use non-Azure resources. What I find is a lot of clients of ours have multiple clouds, or they have cloud and on-prem. They've got all kinds of different situations going on. And so Event Grid helps bridge the gap across non-Azure resources to go pull things in. Again, like events, right? Event Grid isn't a data pipeline. We're not going to use Event Grid as a data pipeline. It's not going to give us the actual object. It's just pub subbing events that we want to flow through. Kind of in this event message thing. So Event Grid does events, which is obvious by the name, but that's how that works, right? So Event Grid is just going to say, hey, this thing happened, or this file was added. Now you've got to go to the bucket, the file yourself. Event Grid. Now this is also important. So we had a situation. The team that I work in, IoT devices were sending data to an event listener, and what would happen is something along the edges, something consuming these events, would fail, and that event would drop on the floor. And so essentially resulting in data loss, right? Nothing picked the event up. And so therefore it got dropped, and now we've lost data, and that data, we can't get it back, right? And so that was deemed unacceptable for this particular application. In some cases, that's fine. Like if you're ordering a pizza and the pizza ordering system on the back end is down, you don't want to collect all those events for an hour and a half while you get this thing back up, and then all of a sudden you've got 1,000 pizzas that nobody wants anymore, right? Throwing an error and letting that stuff go is just fine in that case. In the case that I'm talking about with IoT devices, I can't lose that data. I have to have it. And so Event Grid supports this concept of dead lettering, which means if something goes wrong, you send a message to a queue that doesn't exist, or a message is rejected, too long a message, queue length limit exceeded, all of these things, then it goes to a dead letter queue, and it holds on to it. So you can go process those dead letter events later on, which is super important and saves you a lot of hassle and a lot of potential data loss if something is broken further down the pipe. The cool part about is it's dynamically scalable, right? You can scale this thing or shrink this thing as it goes. As you're processing events, you can go huge or you can go little. Serverless, you don't have to deal with it. Most of these things you talk about are serverless, obviously, right? Low cost. And low cost is important because this stuff costs a lot less than you think it will, and the maintenance of is super easy and low cost. And then at the end, and this is important if this is something you need, at least once delivery is a massive thing, because you will not have data loss as you go through this. Okay, so event grid, if you've got a single event, you're not looking at a whole list of things. If you've got a single event and you've got the need to hold on to those events and not lose them, then that's what you need to do. And event grid's going to be the thing. It's not doing a series of events. It's doing single events kind of as you go. Event hub, service bus. So that's event grid, single events as we go. Let's look at hub real quick. Azure Event Hubs facilitate capture, retention, and replay of telemetry or event stream data. This is the other part of those events, right? So if you're doing a single event, use Event Grid. If you're looking at event streams, we're doing Event Hub. And the data can come from many concurrent sources. You've got data from all these disparate systems all flowing together into one spot that then can be used throughout. Event Hub allows telemetry and event data to be made available to lots and lots of different stream processing services. And it's available as either a data stream, so you can stream the data, or you can bundle events in batches. Either way. So I can take a stream, I can bundle it, whatever I want to do. But this is the key. A single solution that enables rapid data retrieval for real-time processing and repeated replay. So think about Event Hub like this. For the event publisher, it's just an event system. I just publish events up to this Event Hub. On the other side, the repeated replay part, on the consumer side, I can just repeatedly replay these events and treat it almost like a database, right? I can go and pull, hey, give me these things that happened in sequence, and then let's go back in time or forward in time and process that overall. I can also capture all that streaming data into a file, right? So if you've got a stream of data, or you're trying to pull a stream of events from a whole bunch of disparate systems into one place, Event Hub is the tool. Low latency, again, at least once delivery, and this is important, millions of events per second. I said this before when we were talking about scalability, right? These things will scale beyond your needs. Generally speaking, you can scale up to handle whatever throughput you're putting into it. Okay, so that's events, right? So discrete events go to the grid, series of events go to Event Hub. Now we've got service bus, right? So, and you can probably tell as I walk through these things, service bus is going to be for messages. I even have the envelope, right? So service bus, I'm not going to belabor this. Service bus is something that you've seen before, right? Service bus maybe has been around for a long time. Service bus is not new to Azure. It's traditional enterprise applications that need to process messages flowing through a system. Um, enterprise applications require like transactions, ordering, duplication detection, instantaneous consistency. I want to make sure I don't process something twice. I want to make sure if something fails, the entire transaction fails. I want to make sure things are processed in order. That's important. Those types of things all flow into Service Bus and help you deal with how messages flow and keep everything kind of intact and the way you want it to be. Also, very important, Service Bus connects to existing and on-prem systems, right? You don't have to only be in Azure. You can be anywhere you want to be and flow all those messages up into Service Bus. Also, in this case, now we can talk about queues. So this thing gets published to a queue and it gets picked up from a queue, right? You can have a whole suite of functions looking at a queue, waiting for a message, and then just round robin through those functions and get things done. It doesn't have to be subscription based. I can go and just work a queue and process orders that way. So you've got two different options there. And so ultimately it comes down to this. This is the thought process around these three tools, right? So if I'm just reacting to something that's going on, to a single event, I'm going to use Event Grid. If I've got event streaming, I've got series of events, and I want to pull a whole bunch of stuff from a whole bunch of different places, I'm going to do an Event Hub. If I'm just doing a standard normal enterprise application, I've got messages that I've got to process, I'm going to do a Service Bus, right? Those are the decision points you have to make when it blows across these three different systems. And this is kind of how it looks, kind of in the full-blown system. You can link these things together. So I've got an Event Hub that's going to capture a file. It's going to drop it into a bucket. It's going to shoot an event up to Event Grid. Event Grid's going to call a function that's going to go retrieve that file. We're going to go to SQL Data Warehouse. We're going to get that all done. These things kind of plug and play. And that's the benefit. You can have a Service Bus that pulls a message, and one of the things that happens when that message gets pulled is it goes and fires an event. And then it also does some other things with it too. Like these things kind of chain together, and that's the beauty of it. All right, back to this, because this end piece is important, right? So Azure Functions, and if you're not using Azure Functions right now, I would highly encourage you to do that. So real quick, Azure Functions are on-demand pieces of code. That's all they are, right? So I've got a piece of code that's not attached to anything, and I just need to fire that piece of code off, right? There's no infrastructure involved in any of this. It's I say there's no infrastructure, and I even have a pretty picture that says no infrastructure. Yes, obviously there's a server somewhere that's going to run this thing, right? But the point of no infrastructure is you don't have to care about it. You don't have to worry about what version of node this thing is running or any of that other stuff. You don't have to worry about Docker containers or none of that stuff matters to you. All you know is I've got a little bucket of code, and when this thing happens, this code spins up and runs, and that's it. That's the end of it. I'm going to code in response to events. So the cool thing about this is when an event happens, these things will fire off automatically. I don't have to worry about spinning them up and spinning them down or any of that stuff. When an event occurs, my function will execute. What events? Lots of events, right? I can do webhooks. I can do HTTP. I can do queues, blob storage, Cosmos DB. Any event that occurs can go and fire off an Azure function. And that's the beauty of an Azure function. And Azure in general is all of these things kind of talk together. But for this talk specifically, the context we're in now, Event Grid, Event Hub, Service Bus all support functions, like as the endpoint. And so that's the beauty of this thing is I can go write little discrete pieces of code. And when an event happens, it's just going to go fire off and hit this little piece of code. And if that little piece of code gets busy, that'll scale up automatically. And I'm only scaling the little piece of code. So my costs associated with scaling up a little function is significantly lower than trying to scale up an entire application when I start hitting load. It used to be that a function would spin up and spin down and it was over, it was done. Well, that's not the case anymore. Now I have durable functions that allow them to then go and spin up a whole bunch of other processes and pull things down. So I can use durable functions now to spread out my workload. And so a message comes through my service bus, I call a durable function, and that function goes and does a whole bunch of stuff and pulls it back and then responds back. So that's right. GraphQL, Event Manager, all these functions, and this middle piece becomes very important in making sure you've got the right tool for the right job. Because ultimately, this box in the middle, right, is super important to make sure your application does the things that you want it to do in the right way, working the way it should. All right, so that for the most part is kind of my blazing fast walk through this process, right? So making sure you've got GraphQL and an event management system that works for you. Picking the right tool from the box is the most important piece of this whole thing. And then I've got functions on the backside of this that'll go and process all the little messages that work through. And so that's the idea. That's what we're working through as we go. If you have questions, you can hit me on Twitter right there, or there's gonna be a room that we can go hang out and chat. It's always difficult because I know there's people are watching and there's potentially questions, but as we go through this, I think we'll do some questions now if there are any, and then later we can go hang out and chat in a room.
Mike is saying thank you for the presentation. Let's see if somebody has some questions. I'm going to read them to you out loud now.
Okay.
If not, a quick reminder, under our stage, there is a button. It says chat with a speaker. And you can go there. Jonathan will be there to answer to all of your questions. Up to 9 people can join with their camera. Yurati is saying thank you. Oliver saying thank you. Michael. Okay, and Robertus is saying, is it a good idea to do logging through messages?
So logging through messages, that is a incredibly, I want to say loaded question. I don't know if that kind of goes, there's a lot to that. So if it depends, which is a very consultative thing to say, right? But ultimately, generally, if I want to do some auditing or something like that, I'll flow things through an event hub, or an event grid in this case. So using the tool, so I'll just flow things through eventing that way. Depending on the scale, service bus may not be the best place to just throw logging, unless it's additional to other things that you want to get done. Now you can ask somebody else and they might give you a different answer, but that's kind of, in my experience, I would rather use an event grid for stuff like that than sending things through the service bus.
Okay, we have question from Mike.
Yep.
Why would I ever want to use event grid when I can have the event hub, which, if I understood correctly, can do batching and dead letters?
So, okay, so let me go back kind of through. Let me go to my screen that's why I kind of left this up. Let me get to the one that kind of explains the whole thing, right? So Event Hub is about streams, right? So okay, rephrase the question back to me again. Is it why would I ever use Grid when I can do hubs?
Yes.
Right. So an Event Hub from a consuming side is more about events in sequence. And so I'm querying events kind of in context with a larger thing, and that potentially is overkill if all I'm doing is processing a file, right? So if I've got there's a backup system that we have for one of our clients that when a new file is added to a blob storage, it fires an event, and that event through Event Grid, and at the end of that, some piece of code picks that file up and sets it somewhere else and timestamps it. I don't need all the infrastructure of replay and a series of events or none of that matters to me, because once I've backed that file up, it's over. And so Event Hub in that case would be way overkill for just tracking the single event that happens. Hopefully that answers your question.
Amazing. Thank you so much, Jonathan. Olena and Robertus is also saying thank you for your presentation. We're very happy to have you here.
Yeah, and I very much wish I was there. But next year, hopefully, things will be back to normal. I'll be back in Vilnius. All right. Thanks, everybody.
And just before you go, we still have 2 minutes, so I have a question. You said that you have your favorite restaurant here in Vilnius. Can you tell everybody for the next experience it themselves? What is the restaurant?
Queensbury. I would attempt to tell you what streets it was on, but you would all then make fun of my horrible ability to pronounce Lithuanian street names.
That's okay.
But right, it's down there in the city, and yeah, Queensbury. And Queensbury. It is phenomenal. And I'll leave that there. Just to make everybody jealous. The potato things, somebody tell me what these things, the potato things are phenomenal. And I can only ever get them in Lithuania. I don't think they exist elsewhere. I'm sure they do, just in a different name, but yes, but Queensbury. And I will be there next year, guaranteed.